The circuits are sparking, can you hear it? Charge to unveil. Nathan's working through the stormy night, defying physics, unlocking light. In a world fueled by power unseen, high voltage dreams, they reclaim the scene. We fly high and we soar above, finding energy, push and shove. With gravity waves, we'll break the chains. In Nathan's realm, we fuse the flames. Reverse engineer, the gravity flyer hums. Beyond the fringes where knowledge runs. Magnetic fields, they pulse and weave. A world of wonders we can't conceive. Electrons dance in the midnight air. Nathan's path leads us everywhere. We fly high and we soar above, finding energy, push and shove. With gravity waves, we'll break the chains. In Nathan's realm, we fuse the flames. 0-point energy, truth unveiled. In a world where nothing ever failed. Through the sparks and wires we ascend. Nathan's wisdom to the end. We fly high and we soar above, finding energy, push and shove. With gravity waves, we'll break the chains. In Nathan's realm, we fuse the flames.
Welcome, everybody, back to the second episode of The Sesh. Today, we have a very special guest. One of our team leader, Nathan from Old Man Builds, is here. How you doing, Nathan?
I'm doing great, Ben. How about yourself?
I'm doing great as well. It's great to have you here and specifically have you on The Sesh, where we have an opportunity to dive into some of your story and how you got started with all this. So for my first question, I just wanted to know, what got you into building things in the first place? Was there a specific moment or influence that sparked it for you?
Well, my dad was a cabinet maker and a general contractor, so being around a building site all day was normal for us. So I guess I got more into the mechanical end of it when I was a kid. Used to take sprockets out of your bicycles. Never wrote down anything, just completely tore them apart, put them back together. Got into electronics, doing the same thing. Learned every little part, and then turned around and did machinery, welding, things like that. And yeah, just got into more fabrication than anything. So I had a real knack for learning things quickly and being able to process it and put it back together just as fast.
So you had a keen intuition for it.
Absolutely.
And it shows, it definitely shows with your working with what I've seen and everything. So what is specifically, anything guided you towards the electronic section? Anybody help you out in that way or mentor you along the way?
Yeah, my mom used to bring home these projects. She worked for a company that built harnesses. So she'd bring them home and she'd have to do a second job at the house. So we all chipped in to help and build these harnesses, back shell them, put on the little ends, connectors, solder, use a solder pot to just dip the ends in there. You know, anything we had to do to pitch in to help the family, that's what we did. So electronics is like second nature. As soon as I sat there and started soldering, the first thing was hooked. So pretty much after that, it was just guns a-blazing, man. Whatever we had to do, we did. And, you know, it was a nice thing because we made a little money. It wasn't all that much, but the house got ahead.
Well, that's always definitely a plus when you can help out your family and also, you know, make a little extra on the side.
Paid for my first Nintendo with that.
Yeah, exactly. Yeah, that's nice.
bought the old school NES. You know what I mean? It was one
Yeah.
of my first paychecks. My brothers bought the games, and we
Was
used
that
to
the
play that all the
16-bit?
time. Yeah.
Yep. I had one myself when I was a kid. That was the old school consoles. Honestly, I favor them over the new school consoles.
Yeah. So, some
But
games, yes. Simpler.
exactly, simpler time. I don't know. But to go back on topic, what was do you remember your first major build or anything that stands out as your first significant like accomplishment regarding building something interesting or?
Well, the first thing I started building was high voltage.
Hmm.
So, first thing, bought a ZVS, bought a flyback, and started building it. And everybody likes to see a little bit of sparks here and there, get zapped once in a while, and keep the hobby going. And the first part of my whole channel and everything I did prior to that was just high voltage. So I had to learn about it in every different way because there's just not a lot on there. You get one guy that shows you how to hook it up. Not a lot of people experiment with it at that time. And the difference between AC and DC wasn't as well known as it is probably now, hopefully. But you had to kind of go through it like a little pioneer and make your flag drops every once in a while and find out what it's really about. And that was one of my first builds right there. And it was just something simple, just a little saw blade and a little rod, and then just putting the high voltage across it, moving it back and forth, getting it to the spark level, then getting it to go out into a plasma and, play with it from there. So that was the first significant build that I did, was just a simple plasma display.
Nice. So how exactly did you move from high voltage, playing around with that, to specifically fringe science and the divisions that we're seeing you work in now? Is there anything that specifically gave you a push to that, or maybe something that convinced you, there's something here that's worthy of investigation?
Yeah, I did a experiment, and like everybody else, when you first start in this, you just look for anything you can to put on your channel. And I always thought, well, let's see what granite does. It's always been this special thing. We're all into the pyramids. So I just did a little test. I go, well, is it conductive? Is it not? And I watched on the YouTube where somebody said, okay, put it in water and it's conductive. I go, well, this is awesome. Let's just try it, right? So I bought a multimeter, grabbed some granite, bashed it up a little bit, threw it in some water and checked it. Sure enough, it was conductive. He had pulled it out of the water. I just said, why bother? Let's just put it in the water and do it. And sure enough, conductive in there. When you took it out, it was non-conductive. So there was something going on there. So I go, okay, well, one's good, but more's got to be better, right? Always more's better. So I set up 5 bowls and I put a wire in between each bowl. And then I simply checked the conductivity from one end to the other. Now, just to be sure that I wasn't going crazy, and because it would go and it would rise and it would show the conductivity level, I just took out the granite. And lo and behold, there was 0 conductivity in the water from one end to the next. So the multimeter is putting in a little bit of voltage, just enough so it can read something, but it wasn't reading anything. So the water was obviously not super conductive at all. So I put the granite back in, conductive again. Okay, all right. So we got something here. We got something to work with, right? And then, like every experiment, you run into a fluke that happens, and it's like the happy accident in your project. So I had it all set up, and what would happen is you would leave it alone, and it would build power or build conductivity until it got to voltage. So it would go and go and go. It wouldn't stop until you did something to change the experiment. If you just left it there, your multimeter would keep reading readings, and they would go up. So I was getting thirsty, so I just wanted to grab a glass of tap water. So I just turned on the tap. I turned it off. Unfortunately, I had water hammer in my system because I didn't turn the valve onto the dishwasher all the way when I installed it. My fault. Again, happy accidents. What happened was it created a pulse wave throughout the room, and it hit the granite, pulsed it, and the energy just jumped. So I go, okay, hold on. That's not supposed to happen at all, right? I thought it was a fluke. So I started playing with the bowls and putting salt and all this in it. By the time I was done, man, I had tried 5 different things in there between, salt, additive, electrolytes, anything. And I even put fluoride in there, which helped with the conductivity, but it didn't give me what I wanted. So then I had to clean it all out, start over. And then sure enough, it was the one fluke thing I wasn't even thinking about was that glass of water. And it gave that pulse wave, and it just got me excited. It was like, okay, we know there's amplification when you get a pulse wave now. So how do we deal with this? So I just said, okay, let's go back to the high voltage. We'll put this one aside. We know we got an ace in a hole for a video later, right? And then I tried it later with a broken multimeter and got discouraged. And I go, well, this is junk. And then, I blew up my multimeter and I didn't realize it from all the high voltage I was doing. So, yeah, that was my fault. And I realized then I should really take better care of my equipment. So at that point, I just, put it aside again. And then as we got to the point where we're talking about the high voltage and trying to describe it, and I'm trying to break down an AC transformer and rebuild this thing because it was having a very bad time with a voltage multiplier. I was trying to build one. I wanted to make a lifter, couldn't do it. And I said, okay, there's something obviously wrong. So let's do this and let's take it down piece by piece and find out what's going on. I got to build the AC flyback. And at that point, I realized what was going on. What they're saying in this stuff is not right. So I took the DC flyback, and like every good inventor, I bashed it to live in pieces and looked for what's inside, right? There's got to be something more here that we're missing. And that's how I found out. I go, well, okay, what they're telling you about this thing is a total lie. It's a total lie. There's not one diode in this thing. Not one. And everybody goes, oh, no, it's rectified. It's rectified. No, not the way you think it is. It just got little slivers of plastic on it. And on those slivers of plastic, they have a little, basically what would amount to copper tape on each one. And as they go through them, it would act as a resistor and a diode. So at that point, I'm like, all right, now I get it. It's really not that difficult. All they're doing is changing the waveform and how it flows through something. So in that, you go, okay, now I can tell AC and DC, and now I understand they're not much different. And everybody always says, oh, no, it's rectified to AC, or it's rectified, it's AC. It's just a sine wave. There's really no AC in it at all. Not the conventional way you would think of AC, because every time you look at AC, you go, I plug my, coffee maker into the wall. That's AC. The stuff I'm getting out of here isn't that at all. It's potential. And that's what I had to come to the conclusion on the fringe science. And that's what kind of let me in the next direction, where I just knew we're dealing with something different here. And they call it dirty AC is what they would call it. So, yeah, they knew already it wasn't AC. They knew it was a potential. So it kind of threw me off from all the people who were doing it online and said, stop. We gotta stop this. Got to go into it deeper. This isn't right at all. We got to fix it. So that's when I started getting on the camera and start talking.
You had the wisdom to ignore the conventional thinking and observe what you were seeing with your own eyes, and move past all the theory nonsense that gets clouded.
Yeah, absolutely. Because it was pretty much junk. It was, we have this conventional thinking, and that's the way we think about it. And if you go against it, you're wrong. So I said, well, they've been a conventional guy, so I'm just going to go against it because I know it's wrong, because I built it. And if I built it, I know what's in it. So I'm better off describing it in everyday terms so people can really understand what's going on instead of some highfalutin terms. And don't get me wrong, if we had to write a physics paper, by all means, I'd use all the right terms for them. But we're not building physics papers on YouTube, man. We are flat out talking to regular folks who just want to know how this works. They don't want to know about dipoles and impingements and stuff like this. They want to know, hey, where does the wire go? How long is the wire? And what size? That's it. That's all they want to know, because they're trying to get to the end of a project so that they can have the joy of playing with this thing. So, if lack of a better term, my job was to show them how to do it so they can zap themselves faster. So they get to play with their toys, right? So in doing that, people really took on to the whole thing of like, you know what? Yeah, okay, we'll just watch the old guy here and, grumpy and stuff like that, and he'll just get it done real quick and show you without all the other highfalutin stuff, and we can all go with that and repeat it. And that's how I started on my channel. They all started going, okay, well, he's obviously can do his job and build it. Then he can tell us what's in it. Then he can do it again so we can see it again. And then he'll find ways to cheat the system that we didn't even know were there. So one of the cool things I did was go, okay, I want frequency in this thing, but I want my frequency in it. I don't want yours. I don't want what you sent me from the store. I want what I want, right? So I go, okay, let's take this MOSFET in here, and I got disillusioned with those real fast after I blew 20 of them. I just said, okay, that's junk. Let's look for something else. We need a 555 timer, and we want it to be cheap, but we want it to be reliable. So I just went down and I got something from Amazon, and it was a simple, 555 timer connected to a duty cycle, so you can change the frequency and you can change the duty cycle and something. So the cool part about that is I had no idea if it's going to work. And I looked at a bunch of things online like everybody else and go, okay, this might work if you do this and that. Put it together. Thankfully, after probably about 20 tries, I got it to work and work properly. I bought some more parts. So about $15 worth of parts solved the whole problem. And compared to what you could spend and how much time you could spend doing all this yourself, just knowing how things lay out and flow, absolutely amazing way to look at things. Makes everything easier if you know the flow. So I did that, and I just changed the frequency. Now I have what I want. And you learn golden rules along the way. And it's not something they write down. To this day, they still haven't written it down. Even though I've told them 500 million times how it works, they haven't written it down. And I have a whole book full of concepts that if you follow, I could take out all of the weird anomalies in every single one of your projects, because I account for everything where they account for half and say the rest is, I don't know, magic, boogeyman coming in and striking matches in your project or something.
Right. I know one of the largest appeals of your channel is that you have a knack for really breaking down the science in a way that general audience can actually understand how it's doing these phenomenal things in how the energy is moving in the system in a way that provides those, that phenomenon. So that is really commendable. I know I tune into your channel for that very reason. But I know you're also known for reverse engineering the graviflyer. So other than Alexei, though, are there any other inventors or scientists that maybe have inspired you in your work?
There's a lot. Jared out there was doing really good work, and so with Charlie C on the graviflyer, and I talked to them for quite a bit. And like any project, it wears on you for a while, and you kind of get tired of it and put it aside for a while, and then you come back to it. And it did the same to me. But there's a lot to learn there. And let me just say this. Regardless if it ever flies or not, I could care less. And I know that sounds bad when you're reverse engineering something, but it's a teaching tool more than anything. So you get into this thing and you start building it, right? And you get to put high voltage in it, which is absolutely awesome, by the way. When you start throwing masterful, 20 kV at this thing and just watch it light up, it is the most fun you ever have in your life. But there's a learning here. You can't put that much voltage into a system and expect anything good to happen. It pretty much fries your system. So the learning is, how do I do something in low voltage, which will have an effect of giving me massive voltage? And that's the learning of the graviflyer. The other thing you learn in here is that graviflyer is really a field generator. So you think, all right, how is this thing going to lift with 3 pounds of weight? And in order to do that, you have to cancel out the gravity around you. that means you have to build a bubble. And I think anybody who works on anti-gravity will tell you got to have a bubble around it. And this thing is perfect for teaching you that if you take the time to do it. A lot of people don't do it, so they don't understand it at all. So when you ask them, how's your gravity flyer project? And they go, well, I shoved 20 kV into the gravity flyer and made a lot of sparks, right? And you go, well, okay, that's not going to work. Okay, you won't even build the field at that point. So how I ran across it is I did a simple experiment. I saw a guy lifting this little paper lifter, and it simply sat between two plates. And you put a Wilmshurst machine on it, and the static electricity would lift it. And you go, well, that's pretty cool. That's not normal. Can I do it with two flybacks? And you go, okay. So I put them together, and I got my amp super low because, again, playing with high voltage, knew how to do it, created my circuit already. I got my frequency really high. And what I was able to do is take this thing and lift it with high voltage where everybody else uses static electricity. And in that, you get a real insight. You go, okay, hold on. I just did something with energy they said would never work. Why they're telling me this over here works, so I should go in the static electricity direction. And I go, well, I don't have to. I could do it with regular, flyback and that system. So I go, okay, well, let's amplify this. Let's draw those amps out even further. So I did, and I got this thing to pin that whole thing. It was hard to move that thing. You would literally take a plastic ruler and bend it before you moved that thing off of there with the much suction it put on it. Well, once you know that and you understand that you just put this thing in a dielectric field and then you saturated the piece of paper beyond what anybody else will do, and that's why it sticks down to the ground, you start to learn about gravity. So then I go back to my gravity flyer and I apply the rule. We just have to cut out a lot of the sparking. We need to go very high frequency, high voltage, very low amps. So we're talking milliamps, 0.05. We're talking really low, where it's like mimics static electricity, but still has a bit of heat in there for a magnetic field, right? So I go, okay, we'll do that to the disc. So I started getting good results. It started to put up a bunch of static electricity in the air where you could feel it. You're going, okay, now I'm getting somewhere. Then I hadn't built a Tesla coil yet, so I looked around and tried to find a Slayer exciter that wouldn't blow up on me in the first 5 minutes of usage. And I go, okay, this isn't working. I had a guy contact me and says, look, I found this one that I pulled out of a speaker. Why don't you try it? And I go, okay. So I put this thing together. Sure enough, 40 volts all day on a Tesla coil that was, by the way, 50% out of resonance. That didn't even resonate right. But it again tells you another story. So when I connected this to the center plate of my gravity flyer, I noticed that the frequency of my Tesla coil was now at 20 hertz. Again, man, happy accident. So I learned right then and there, how do I change the frequency of a Tesla coil? The number 2 coil was set to 750 kilohertz, but I'm getting 20 hertz out of it. Didn't make sense. The imbalance between the primary and secondary was the deal. That's how you change the frequency. You have to add a load down the center of the Tesla coil in order to get that frequency to change, because you're adding capacitance to it. It was like an aha moment. You're like, yeah, I got this thing, right? So it's unheard of. So everybody was questioning it. So we did a sound test on it. Sure enough, came back 20 hertz, right? It could even be lower if my mic would pick it up. It can only pick up down to 20 hertz. So I could have been around 7 hertz for all I knew, right? But again, teaches you a lesson. The next step was, so what is this Tesla coil and high voltage field doing in this gravity flyer, right? All right, so we put them on there together and you don't notice anything. So what is the first thing that you do in a project where you don't know what it's doing? You reverse it. Okay, well, if these fields are supposed to be doing something and holding in a bubble, then by reversing it, I should be able to expand the bubble, right? Makes all the sense in the world. So I took my high voltage, put it to my center plate, just the positive. Then I turned around and I took my wire and connected it to my top disc, put it down through the center of my Tesla coil, didn't attach it to any part of my Tesla coil, and then round the wire to the bottom. What started to happen was the bubble would form in static electricity on the outside. Then the Tesla coil field would build on the inside. But the more energy you gave it, it would build out that bubble further and push out the static. If you went too far too fast, 20 feet was not a problem to push that right across the room. You would literally light up light bulbs across the room when you do it. You just start shoving this stuff everywhere, right? The computer hates you. It's binging every 2 seconds. You know what I mean? You hear it in the background and all the testing I'm doing. It's like, man, he must be torturing that poor thing. But it comes to a point of understanding. It's like, okay, if it pushes it out in the opposite direction, it must be holding that field in. One's holding the other and pushing the other. And what it came down to was the temperature of the two. One was hotter than the other. The magnetic field was hotter than the static field, which is cooler. And that means the hotter field pushed the cooler field. It's no different in the weather outside, but seeing it in an experiment kind of blows your mind. Again, another point. Let's write this down. You know what I mean? I have another learning experience. So far, I got 3 big ones here, right? So I'm going, all right. Now, which state am I in my electricity? I said static all the time, but what if I didn't want static? What if I wanted a scalar field? Those are not easy to pull off, right? But if you simply understand how your voltage works and you go, if I put it closer, it sparks. If I move it a little further apart, I get plasma. What if I wanted a state where I pulled it apart, but I don't want the plasma? That state's scalar. That's where you want to be. So your distances in setting something up changes it. Now, what kills that field? A spark kills that field. So it'll automatically change to a different state. Hey, there's another big understanding. We got a whole checklist going on here, right? Now, when you start to put this thing together, you go, well, I got a field on it. I got the right electricity. I know to bring the amount of energy down, and then the field will grow. I know that my actual Tesla coil field, hooking it to the center, will push that scalar field just a little bit. Now I got a big amount of energy here, right? Now it comes into the next understanding. I put the gravity flyer on the ground. Then I grounded my Tesla coil out. And I go, okay, why are the feet of this thing sparking? What is going on here? There's no reason for that. You shouldn't have concrete sparks. So you do what everybody does. Well, what I do, let's try to remake the spark. You know, let's just take the number 2 part of the Tesla coil and let's see if we can't just make sparks from the ground. There's got to be a reason for this. If that's what's connected to the frame, that's what it be, right? So it didn't work with the number 2 coil directly. It would get some sparks. It wouldn't get a whole lot. Not what I was picking up in the flyer. Put the wire down the throat again, started sparking it, and I go, oh, okay. Now we got something here. It's making a connection between my ground wire and my Tesla coil, then to the not connected wire that goes down the throat. It's now making a loop in the ground. The concrete's becoming electrified underneath it as a capacitor, not in the concrete itself. Concrete itself was just like a layer that covered it. It's the ground that's doing that, and it took a little while to distinguish that. So you go, okay, now I know I need to have double grounds on this. The gravity flyer has to be on the ground, can't be on the countertop. It has to now have a grounded Tesla coil. Okay, well, now we got something. So you start to wonder, okay, this must be where he started to learn how to ground things to get some power out of the earth, right? Again, it's all in an understanding of a gravity flyer. As you've worked through these things, and you go, okay, well, we started getting into Bedini a little bit, right? And I go, okay, what's going on with my magnets? Because I started getting things that are heating up the plate. I noticed, I go, let's put a temperature gauge on the actual gravity flyer and see what it is. Since we're running it down the center, 74 degrees. You go, well, that's kind of odd. I'm putting high voltage in it, it should be 90 to 120. You know what I mean? That at 74 degrees, that's what the temperature in my room is. And then it starts to kick in. You go, okay, all right, I got a big pair on me. I'm going to go and try this. I'm going to put my finger on that plate. And again, 20 volts. Let's see what it does. You know what I mean? I told my wife, be ready. You know what I mean? Going to the ambulance if something happens. I go and put on there, and I'm sorely disappointed. I wasn't shocked. Nothing happened. And I'm going like, what the is going on here? Are we getting power? Oh, yeah, we're getting power. But the old man ain't getting shocked. So then I started to rub the outside edge, and my finger gets burnt. I'm going, okay. This thing's cold, but my finger's getting burnt. This isn't right at all. This is like Bizarro land. Like, we literally walked into the Twilight Zone, and I'm wondering what's going on here, right? Okay, we're just going to have to keep doing tests. And I'm showing these, by the way, online and showing my testing, and I don't think anybody's picking it up, and they probably wouldn't unless they were in the room with me, pick it up, fully. And I go, okay, now we know we're having an unnatural connection with the ground that nobody else knows about. We got this cold place here. It's hot on the end of it. We got electricity that's in scalar. We created a bubble. We are getting somewhere with this. So I started telling people more about it online. Hey, this is what's going on. I'm not playing around. Let's go back to the magnets for a minute. What was happening is every time you turn the bottom disc, the magnets would hit the center plate. When it hit the center plate, it put a frequency in the center disc, right? So I'm going, okay, I know that's happening. And then you try to overdo it. So I overpowered it. Okay, I put a lot bigger magnets in there, bigger magnets. Everybody wants a bigger magnet, right? Put in bigger magnets and it just screwed up my frequency. I'm going, okay, this isn't right. This is not going to work. So we went back to the regular magnets, and I go, well, I'm having less luck with these too. So I put in some regular ceramic rare earth magnets, the wall, hanging on your fridge kind of magnet, right? I started to have some good luck with this thing, and I'm going, okay, we're getting the right frequency, not overpowering the system, and we're starting to get the right fields out of this now. I'm not getting something that's ruining the effect. It doesn't make my center plate hot because I was getting hot electricity turning off my cold effect on the center. All right, now we got that figured out. Okay, now what I'm learning every single time I go to overpower this system, I'm failing. It's not working. It never works when I overpower it. It only works when I put it in the correct power. That's when I started to think, we have a different phenomena of energy going on here. It's no longer hot power. It's got to be cold power. It's got to be something on the opposite scale of what we're normally getting. And when I say that, I just mean at room temperature, it should just stay at room temperature for cold or go below. Anything that goes above it is considered hot energy. So normally you put a coil to a DC source and that thing, it's on fire within minutes. But in this case, we had a ton of voltage, not on fire, not even hot. Okay. The hardest thing to get over is when you go, okay, now that we have all this understanding, we have it on the ground, we have it started up, we have it going, we have so many things checked off our list of understanding that most people just would never think of. And you go, okay, now the power starts kicking in. It just, out of the blue, you let it run 20 minutes, and then all of a sudden, this thing just quadruples in power, just like that. That just started, you start seeing it, and this thing starts turning on you. And it normally wouldn't turn. It's all based on the speed of the disc, right? No. This thing started turning, and it turned in one direction. And that was it. And I'm going, okay, what's going on here? So if you're looking at this thing, it's turning to, would be my left as I'm looking directly at it. It turns to my left and starts to pull the feet off the ground. And I'm going, okay, hold on. How did I get all this power? Why is it doing that? And is it going to go the rest of the way and give me Yahtzee, right? Because 1 foot off the ground, 2 foot off the ground, somebody in the comment section's always going to go, oh, it's just a fishing rod. You got a fishing rod over there. You don't know how to work it. You're a bad fisherman. You know what I mean? You got a string somewhere, you know?
Right.
Yeah.
And how do you deal with those skeptics, though?
You know, everybody's got an opinion, man. And at first you go and say, all right, this is what's really going on. And they didn't care. And you finally realize, hey, they stopped by to tell you you suck. And then they moved on. They didn't even watch your video. They have no idea what's going on in it. They just want to tell you you suck. They saw the original project, and anybody who's building it sucks. And that's what they think. So you're never going to convince them. And putting out something that's not all the way is never going to convince them. Sure, you get a couple guys that go, man, that's exciting. It did this. No. Then you're just going to expect me next week to lift it. And when it doesn't happen for God knows how long, you know, it's going to be, what am I going to do with it, right? I'm better off just telling you about it and then just letting it be. And that's what I did. So I have all these magnificent discoveries that literally, if all you did was learn how to make a field bubble, man, you'd be a superstar. If it didn't say gravity flyer on it and you said, I created a field bubble for a UFO, people would be like, what? You did what? Mm-hmm. Oh, let me have that. And because it's got a stigma attached to it, people don't do that. If you say, I know the states of high voltage and I can put you in any state I want to without it flipping out or changing on you or sparking over, they'd be like, really? You could do that? But as soon as I say gravity flyer, they're like, oh, you're a fraud. You're a punk. And I get that all the time. You know, I don't really care. I'm reverse engineering it for me. And you want to come along for the ride, you come along. If you don't. That's great too. You know what I mean? And so what finally happened with this thing is I just shelved it after a while. I said, you know what? I know I'm getting a ton of energy. I know I'm doing things. Let me put it aside for a while. I'm not getting the reach that I need to in the community about it. So we started the Friends think Tank, you and me. We got this thing going and we got people to listen and more people out there. And I said, well, maybe I'll bring it back. You know what I mean? After a while, Gerald got involved and I go, oh man, I'm learning a lot. The conversation between the three of us led to this whole journey that we go down next. Okay. It doesn't happen without the combination of the three of us. Just so you know, it doesn't happen by me alone. It may take, several more years. I'm sure it's the same with you and same thing with Gerald. Well, Gerald, I think, was already there before we got there, but the understanding.
Yeah, Gerald was miles ahead of us.
Yeah. The understanding and validation part of it is, I think, what came up. And we all kind of go, okay, yeah, we're all on the same page here. And so I started messing with my Tesla coils some more, and I go, okay, this right here is fantastic because I got things already nobody's gotten. And that's when I met Sean. He came on and I was frying my Tesla coil. Okay, it wasn't even funny, Ben. I literally took this thing and it was starting on fire. Like, you'd see it over here smoking, and then I walk over to it calmly and go, well, that's the end of the video. And I go, shut it off, right?
I remember that.
Yeah, it constantly happened. And I'm going, man, I really suck at this. I'm trying to start a new system. My Slayer Exciter works great. My ZVS Tesla coil was an absolute dumpster fire. And so Sean stepped in and he goes, Nathan, I can help you with this, right? And then I didn't hear from Sean for a little bit. And then he come back and say, I can really do this, right? I go, all right, let's just meet up, right? Let's just talk about this. So I get to talking to Sean and he starts sending me stuff on email and I'm going, all right, this is what you do and this is how you do it. And we started formulating a plan. All right, how do we make this easier for somebody to understand? What are the numbers? And a lot of time when you talk to people, they get into theory real quick. And you'll notice one thing about me, I don't do that. Not when it comes to I want the answer, right? I get very direct and I go, okay, is it more or is it less capacitors? I don't need the theory. I just need to know which way to go. Okay. Make it simple for me, caveman over here, make it simple and we'll get through this, right?
Exactly.
So Sean understood where I was coming from. So what we actually did was we set out a way to formulate a plan for every Tesla coil that hooks to a ZVS, and we found our frequency range, 260 kilohertz to 400 kilohertz. If you're in that range, every ZVS will work. And then you just got to change your capacitors. You swap out the two there and put in 1.50 nanofarad capacitors. You put 2, so it gives you down to 0.75 nanofarads in the whole system. Perfect. It'll run in that range all day long. So I said, okay, let's pick a middle range, like 300, and let's shoot for that, right? For every coil. So we found a way to make Java PC, or Java Tesla coil thing to print out what we want, right? So we manipulated the system, and Sean went over that. Thankfully, he's real good at figuring all this out. So we did that, and we got this Tesla coil that's perfect. It just perfectly runs. Sits in resonance without a problem, and this thing shoots out 13-inch lightning bolts out of the top on AC, which is absolutely amazing. But in DC, it puts out a huge field, and I'm going, okay, now we got a Tesla coil that I want. And it didn't seem like it, because Sean goes, well, why are you putting more power? You're overpowering, right? Not what I'm looking for. I want the suction on this Tesla coil to be right. That sounds funny, right? Doesn't sound right at all. Why would you be talking about suction on a Tesla coil? It doesn't make any sense. Tesla coil doesn't suck. You know, it's the ground line when I hooked up my gravity flyer that I wanted to have that suction, because it's just a pump. It literally, it oscillates. It just pumps up and down. So it's sucking the energy out of the ground and giving you 20% more on your Tesla coil. So again, if you're looking for these anomalies, you go 20% more? Really? I could use 20% more. And then, you know what I mean? So you go, I'm definitely grounding this sucker out, right? Boom, right in the ground. So that's what it was for. I just wanted it to give me a little extra out of that side of it. Now, again, because it was cold, it was the opposite side of what you're doing. And you're like, hey, this is cool. What it does is it creates more magnetic impingement, which gives that wire down the throat, gives you more energy coming out of there. Even though it's still cold and it hasn't heated up yet, there's more energy in it. And you're going, okay, now, how do I use less energy that's wasted? Because every time it creates heat, anytime it creates plasma, it's wasting energy. Now, in the cold side, I'm not wasting any energy. All of it's mine to use, plus the extra 20% I get out of the ground. So I go, okay, now we're in business, right? So again, Sean is an absolute master at Tesla coils, okay? He uses every little device in the world that unfortunately I don't own yet. And he gets these things perfect, so he taught me how to do it. And like a quick learner, I knew right away once I got it done, now, Sean, it's time for me to shine. Now it's time for me to push this thing beyond the limits and try different things all over the place that you would never do, right? So that's where the real fringe starts coming in. Start playing with the ground. We start telling you and start telling Gerald, hey, we got this thing that's grounded out, right? It's so cool. And Gerald's just smirking over there like he's got this big bag of beans that he doesn't want to share with me. And it's like, all right, dude, I know something more is there. I'm going to experiment because you can't wipe the smile off your face, right? So he already knew to double ground it. He already knew in a different way with his system that, hey, your gravity flyer played a part in grounding, and as well as your regular Tesla coil grounding it, you're going to get better results. Well, little did we know it was going to lead to the capacitor in the ground and that whole effect. So we had to prove it out. We kept getting people, oh, yeah, you guys talk, you smile at each other. You know what I mean? It's like a couple of schoolgirls talking, yeah, blah, blah, right? Yeah, all right, I got something for you. I know a little bit more than what I tell you. So let's do this. So that's where I started playing with the Tesla coil a little bit more and started putting it in water. It was a thing between Gerald and I. Okay, can you put it in water? So Gerald puts it in water. So I put mine in water. I go, okay, my energy works out in water. Yours works out in water. Okay, let's go to the next one, right? I go, let me one up you. I'm going to put it in mud. I'm just going to put it right through mud. It doesn't sound right, does it? You go, who the heck tries to light up mud? I mean, whose mind is bent that much? So I go, all right, put it in the mud. I took my wife's casserole dish and I go in there and I go, all right, this is awesome, right? So I'm going to light up this mud. So sure enough, dude, as soon as I put it in there and I hook the light bulb to it, I go, this thing still works. You know, I knew the water one was working. And now this is working. I'm going, this is a strange phenomenon. So let's just put the light over it and see what happens. Well, as soon as you put the light over it, you go, well, this has more energy than it should. And then you go, this thing has almost 3 feet of energy coming off of this mud. You go, it's mud. You know, we used to do this in front of the house. You know what I mean? When Mama was mad, we're making mud pies and getting all dirty. And now here I am in my garage making mud pies and making energy with it. You know what I mean? What a payoff, huh? So
it's very similar to the iconic Tesla putting the light bulb into the ground. You know, it's very, very much the imagery I get in my head and the direction I see this potentially going. And oh, I'm sorry, I didn't mean to interrupt you.
No, you're good. So we did that experiment, right? And I get a lot back from the community. Did you try this? Did you try that? Is it the mineral here? Is it the glass here? You know, everybody's got something little, their own angle they want to throw on it. So it's like, well, how many tests can I do? I got a couple to choose from. So let's start testing out a couple of the main ones. Was there a flaw in the glass? Was there something going on there where the glass was more conductive than you thought? Was it the water that was conductive only? So you go and you start looking at it and go, let's tackle the glass first. Okay. So we started doing glass experiments. You see me pulling out a barrel jar, kind of one of those things you pickle things in and make them super hot and then burn your mouth and cry later. Yeah, that's about what we were using there. But I had one that I had drilled out the bottom because I was going to do a high voltage experiment where you took out all the air in there and let the voltage go, which is totally cool experiment, by the way. But I never got back around it after I put the hole in there. So I go, well, let's just try this. So I hooked the bottle to the end of it. And sure enough, this thing starts lighting. I'm going, okay, all right. You know what? I give this to Todd right now. He came up and told me glass is probably conductive. All right, so yes, he's right. And Gerald told me the same thing. He said he had a dream and he was told in his dream that glass was conductive. They're both right. It was conductive. So now I'm over here lighting up this thing like it's a power source, right? So I like, you know, any guy, I go, okay, let's throw it down the throat of this thing. Let's put it around it, you know, anything to get around it. Okay. So I do that and I prove out that theory. Then I go, okay, now let's start to get crazy. Let's just start putting a lot of light bulbs on this thing, and let's put another Tesla coil at the end and see if we can't light up the other Tesla coil. Meanwhile, I'm just still putting this rod down the center of this thing. I haven't touched the number 2 coil or number 1 coil at all. I do it, and then I started up the second Tesla coil doing it. I lit 3 big 4-foot light bulbs, and then I lit up the other Tesla coil and a light bulb from that Tesla coil, and I go, okay, we definitely have something here. We're definitely in the right place. So I go, well, what's the next thing that we need to do here? And I go, there's got to be more, right? I go, okay, let's see, since it's holding capacitance, let's use it as a capacitor in the circuit. So I hooked it up, put it to the glass, put it in the capacitor configuration, moved it on to another Tesla coil, just the number 2 part. And then when I put the light bulb down the center, I had reversed the field. So almost no field on the inside, but a heavy magnetic pinch on the inside. Dude, I blew me away. I got this thing, right? This thing is totally amazing. It's good to go. What I did was I broke the frequency chain. So the frequency would normally, every time you hook something to this, would take more capacitance. So it'd throw your number 1 Tesla coil that you started way out of resonance. So it would have been, God, would have had to lower it down to 200 or 150 kilohertz just to get it back in resonance. And that wasn't happening. So I started burning up the little clip that goes on there because it's so far out. But by adding the glass, it broke that. Now my Tesla coil resonates at the normal proper resonance. The glass takes that out of going through to the next thing. The next thing still lights everything up. And no heat up. No heat up at all. I got a perfect system now. Okay. Understand this, Ben. I created a 10-foot by 10-foot moat, is pretty much how I'd say it, in my backyard. And I did the experiment. I literally took 4-foot lights and shoved them into the ground and they lit up. Okay. What you need to know about that is there's silica, sand. It's the quartz in the sand. That's what it is. It's in glass. It's in sand. It's in quartz crystal. That's what's lighting up here. So the next thought in your mind should start to be like, they have a lot of sand in Egypt. They have pyramids with a ton of granite with quartz in them.
That's true.
Did we just find the answer by playing around in the garage with our Tesla coil?
That's incredible. That's absolutely amazing work. And you know, I think that's also a testament to how successful the Fringe think tank has been to both of our research.
Mm-hmm.
And would you say that the work with the Graviflyer though helped you at all with any of these breakthroughs in your reverse engineering Tesla's Colorado experiment?
Like I said, you don't get to that level without doing the Graviflyer and the Tesla coil, learning the double grounding. You don't get to the experience of cold energy without the center plate going cold on you. You know, there's a lot of this stuff that just transfers over. That thing has taught me more than any lesson I could have learned doing each experiment individually. But by having them all combined into one thing, absolutely the most useful tool there is out there if you stick with it. Most people, they just throw high voltage on it and says it doesn't work and walk away. Like anti-gravity is going to be that easy. Yeah, it's like your toaster. Let's go make some freaking toast, okay? And this thing's going to fly. I wish it was that easy, man. But it's not. It's just not. So you have to go through step by step and do this right. Just simply put it out there. And I always say it's like, this is my own personal confession session about what's going on with the Graviflyer. That's what I do when I get up and tell you the theory. I'm not trying to tell you it's trying to move electrons. I'm not trying to tell you that it's doing anything in physics. I'm simply describing what I'm seeing. And in doing that, it's like writing notes. I'm just writing notes to myself. This is what I'm seeing. This is what I'm experiencing. This is how I see it. And that's it. You take it for what you will. And yeah, you don't learn all of this engineering knowledge overnight. And you certainly don't learn it unless you start playing with a system that you have to break down completely. So the Graviflyer, absolutely shows you everything. And it may not be my main goal to just play with the Tesla coil and get all this stuff for the Colorado experiment or moving into the sand area or something like that. You know, I started out wanting to do the Graviflyer and I still want to do it. But man, what a cool thing to look at it and go, I just proved out Tesla's one wire theory. I proved out his Colorado experiment, and I have a chance to prove out the whole entire Great Pyramid all in one shot as a side project to this little piece of aluminum I'm trying to lift in the air, right? I mean, how cool is that? It's
pretty incredible. It's pretty incredible, and it's an honor to be a part of it, to be honest. You know, like we're all working on incredible things and having incredible breakthroughs left and right. And this Colorado reverse engineered experiment is not to be taken lightly. We need more people to have eyes on this for sure, because it's a significant moment. I've never seen anything else like this. You know, I've heard many of our team in awe because they've never seen anything or heard anything like this being replicated before. And it is also a testament to how much you have understood how this exotic energy moves and how you can actually manipulate it within your system. And for people just getting started out into fringe science and understanding, you know, the radiant energy theories and all that, do you have any like tips or any help or any common, you know, misconceptions you'd like to relay?
You know, whatever you do, go into it with an open mind. Understand that, yeah, this looks cool, that when you see it, there's always anomalies in everything you do. Things may be a little bit different than what you see on camera because you're interpreting a certain way where the inventor interpreted a different way. So just go in there with an open mind, but do the basics. You want to test the coil? I'll teach you how to make one. You know, I'll give you the easiest one possible. We're looking at 4 parts, you know what I mean, and the Tesla coil itself, and we're done. You know, you're 10 minutes putting this thing together, soldering it together, and you're off playing. And the greatest thing about it is I'm showing you exactly what I'm doing in every setup. You go, well, there's not much to hide in this. You know, if he really was trying to do something sneaky, man, he'd put a lot more into it. But I want people to replicate it. I want you to do this. I don't want it to be something that, you know, you just look at and go, well, that's too hard. No. I literally took sticks from my garage and put them together and wound a Tesla coil on them in order to get it done. And I showed people that. So don't be afraid of it. You know, that's all that's holding you back is you overthink it and you get afraid of something. And then once you get into it, you go, well, this is so easy. No wonder why this old man was able to pull it off, you know, with a bunch of junkyard parts. Well, yeah. So when it comes to newbie projects, you know, DC flybacks, EVS, buy them together as a set on Amazon for $30. Get yourself an old saw blade, one of those big ones that you hack down the trees with, and it has, you know, lots of bare metal on it that has spikes, and then just buy an aluminum rod, and then hook negative to the aluminum rod, positive to the saw blade, and keep them apart and keep your hands away from it while it's turned on. And 1.5 inches apart, you should start to get some magical results, and already you're in the game. So that's pretty simple. And then if you want to do a Tesla coil, like I said, you could build an easy Slayer exciter that'll last you at 40 volts all day long playing around. All day. Not even a joke. It doesn't even get hot. And you're going, this is impossible. Everyone I see on the internet blows up in the first 5 minutes. Even some of the best inventors can't come up with this.
Exactly.
Well, I'm giving you the way to play with this thing to find more stuff. Because I want you to learn. I want you to get it together. I want you to try it and go, okay, now I can light it this way and this way and this way and this way. And I'm having fun. Now your project's more than just a light bulb turner on, or now you're doing something with it, something important. That's what I want people to know.
Nice. Well, given all that, what's next for you? What's next for Nathan? What are your goals for the next, say, 10 years? What would you hope to accomplish, or project-wise, what would you like to work on?
Well, I'd like to finish out my gravity flyer, and that might be my, you know, the end of what I want to do in electronics. So if I prove out the Colorado thing, and I can help, you know, you and Gerald with anything you guys have going on, and I do my gravity flyer, you know, I'd be happy just to sit behind the mic and have fun and do shows. And then help people. If they want to build a circuit or something, I can help them design it and build it and things like that. But truthfully, I was in retirement before I got here. This is what I do in my retirement for fun. So
yeah,
you know,
just looking to have fun.
Yeah, just looking to have fun. If I can help out, I will. You know what I mean? Knowledge has got to get passed on so that you don't have to start where I did. You can start with a lot more knowledge than I did. And, you know, somebody's going to start cataloging this stuff one day. And they're going to put down every experiment that I did, and then they're going to go through and they're going to put rules to it. And then you're going to have a real theory going on. You know, on the high voltage thing and which field you're in, you can already write a theory on that. I could tell you exactly, you know, how DC power works better than anybody else in fields and stuff like that, and how AC works. You know, in that's a whole nother theory. And like I said, let's start pulling them out from the gravity flyer. We can start building fields on the outside. I can tell you exactly how to do that. I know the fact that it's piezoelectricity and cold electricity, that the fields you have to create. A lot of people don't know that. They're not even clued into that yet. I call it earth energy, and that probably confuses people, or cold energy. It's basically room temperature energy, and it goes a little bit below. I've gotten it to go 20 degrees below, and man, does it pick up power when it does. So there's a lot of just little things like that they're going to be writing down, you know what I mean, and cataloging throughout this whole thing. How did he get the capacitor in the ground? How did he get the light bulbs light up in the ground? Why is there capacitance in granite when there isn't in any water? That doesn't make a whole lot of sense right now to people. Why can't I take piezoelectric buzzer and double my energy as soon as I hit the ultrasound machine button? Like, what's going on there? How come that can't happen with regular hot electricity? Why is it only on the cold side? These are going to be a lot of questions people are going to have. I've answered a lot of them, but I guess they all got to be put together in writing and in a book for people to really kind of say, all right, this is what it is. And, you know, I'm not going to commit to writing it the right way. I'm sorry. I'm doing all the tests. I'm showing you how it works. If you're really gifted at that, then by all means do it. You know, if you're a physicist and you want to understand it and you want somebody that works in the shop and can show you the right way, by all means, I'm your guy. But if you want me to write out the theory, no, that's for people who get paid more than I do. You know what I mean? That's their thing. I'm not getting into it. I'm not going to try to infringe and try to learn a whole nother subject on this. I mean, I'm doing enough, isn't it? You know, I don't have to do that end of it. So I hope they pick that up and run with it and just balance out the system so we have it right, so that when we get out to space and stuff, it works. I don't want to be out there if it doesn't work. You know, I need to bring a Mountain Dew can and my duct tape next time I go on a shuttle or something, or the first time I get on one, I should say, because they're not going to know how it works. So.
And regardless, you're inspiring people left and right to actually look into this where they would just ignore it otherwise. And I think that is one of the most important takeaways here from your channel and the significance of it and its role that will play in future generations. Honestly, I believe that, you know, we're having a big impact by having these discussions, and it's important, you know. So my final question is there a dream team? If you could go back throughout any point in history and pick up any scientist or engineer, who would your dream team be?
I pretty much have my dream team. I don't need to go back. I do want Victor to be able to get back on and to get his computer fixed, and he's a big part of what we do. You know? He is,
and I love Victor. He has such important insights. Like, he blows our mind left and right, and then he blows his own mind. And it's just, it's fun to watch him have those breakthroughs live. It's just a pleasure to have Victor Sears on our podcasts.
Yeah, we all get joy when he gets joy, no matter what it is.
Yeah, he's so excited, and I get excited, and everybody, you know, it's a big happy family, in my opinion, you know.
Yeah, we got a lot of good people, a lot of smart people. I mean, you know, we have Sean, who's just amazing at everything. Ian goes out, man. He builds everything everybody else does. So he knows everything. He's finding every secret. You're not hiding it from him.
Yeah, we have all these divisions of the Fringe think tank, and he's got his, you know, his insights into all of them.
Yeah, Mike's over there building batteries, building, you know, motors and stuff that are awesome. We have you, me, and Gerald, and we all do our own thing, man. It's awesome. And we have the extension of the family that goes out, you know what I mean, to other builders and stuff that come on and share stuff with us. So, yeah, I'm happy, man. You know, a lot of people would say, oh, well, why don't you go back and, you know, pick out a couple scientists and stuff that from the old days. Well, unfortunately, it's going to take a while for them to get up to speed. And we're already there. We're already proving things out. It would be satisfying to see the look on Tesla's face when he sees that we're repeating his experiments he already knew happened. You know what I mean? Just to look on his face like, yeah, see, I told you the future's mine. And he was right. It is. Oh, it's absolutely his.
Yeah.
So
absolutely. I agree with you on that one. And
yeah, that's the only thing I'd like to see.
Yep,
ahead.
it's really been an honor. It's incredible to go on this journey with you and everybody else. But that's really all I had. Unless you have anything you'd like to add to the show.
No, that's pretty much it, Ben. I think that's where we're at for now.
Yeah,
We're doing great work, and like I said, we learned a lot throughout all the projects that we do. I mean, I got a 500 million projects sitting on the table right in front of me that I haven't worked on yet because I got excited about one and kind of ran with it. You know what I mean?
right.
But yeah, I want to finish all those out and then go back to retirement. At some point. But yeah, doing the show with you guys is enough for me. It's totally awesome. I get to meet cool people all day, laugh and joke and have some fun. And, I like that about our podcast. It's much different than everybody else's. They're kind of uptight and they kind of
Right.
keep everything so serious. We're not afraid to bust out a joke here and there and keep everything light and humorous, but put out good quality information where you can build your own stuff. Yeah.
No, I agree 100%, and I like to incorporate humor into the podcast because I just have a sense of humor. I don't try to hide it. I don't try to, specifically hide who I am. We try to be who we are. And I think that's sort of the appeal for, some of these podcasts is people want to see who you really are and not who you're trying to be, and we are just humans. We make mistakes. We say things that we don't mean sometimes. We get in fights, we have drama, but at the end of the day, we're a big, happy family. And I'm very grateful for everything that you have provided me in my research and everybody else in the team. No, I really want to say thank you from the bottom of my heart, Nathan. I would not be here today with where I am in my channel and my research without the guidance of you specifically. So,
Thank you for that. I do appreciate it. I don't know if I did a whole lot or didn't, but if I even just encourage you a little bit to keep going and push further, that's enough.
absolutely, you've done all of that and more. But I wanted to say thank you, and thanks to our audience who is going to be watching this in the near future. So get ready for the next episode of The Sesh.
Right on. Thank you very much for having me, Ben. I appreciate it.
Of course. Thank you, and thank everybody else. Have a good day, everybody.
Good night.
From the shadows, light emerges, breaking through the veils of dark. 0 points and gravity's converge, yeah. Dying voices, revelation start. Ancient whispers call. They're begging us to open our eyes. We stand tall, defy